Let's do another approximation by differentials. In this problem, we augment the procedure a little bit to solve a different kind of problem. We've got the radius of a ball shrinks from 10 to 9.8 inches. And what we're asked to do is, using differentials, estimate the decrease in the volume, and the decrease in the surface area. So these are going to be decreases. So we can note here that the change in these functions will be negative. That is, we expect a negative sign. It's like when we were doing related rates, and it basically depends how you phrase the problem as to how you state your answer. So this is actually very straightforward, but we just make a small change from the last technique. And so we use some formulas from geometry. That is, the volume of a sphere is 4/3 pi r cubed, and the area or surface area of a sphere or a ball, let's see, where did I write it, is 4 pi r squared. So now, just like we did before, we see that the change in r will be 9.8 minus 10, which will be -2/10 or -1/5. And the more distinguished value of r is where we started at 10. And so now, just like we had before, we see that the actual change in v, which is v of r plus delta r minus v of r, is approximated by v prime of r times delta r. And that's where we stop. We're not solving for one particular function value like we did in the previous problem. So all we really need to do is compute this term. So in substituting, that just means that v of 9.8 minus v of 10 is approximately v prime of 10 times -1/5. And so, of course, we just need our derivative, so we can use our power rule. The 3's absorb, and we just get 4 pi r squared. So now this change in the actual volume of the sphere, we'll see, will now be, in this case, the derivative 4 pi r squared. R is 10, so we substitute 10. And of course, the delta r is -1/5. So this will be 4 pi times 100 with the negative divided by 5. And of course, 5 into 100 is the 20. So that gives us -80 pi. So we state this as decrease by 80 pi cubic inches, just like we did with related rates. Now for the area, we have the same formulation. I wrote this in the blue box here. That is, the change in the area, that is a of r plus delta r minus a of r, is approximately a prime of r times delta r. So again, all we need to do is evaluate this term. Now when we look here, using the formula for the area of the sphere, we just take the power rule again, and we get 8 pi r. Very simple. Then the substitution is like the last problem. So a of 9.8 minus a of 10, which is the change in the area, is approximately a prime of 10 times delta r. And substituting the derivative, we have 8 pi times 10 times the -1/5. And of course, the -1/5 times the 10 gives us the -2, so we get the -16 pi. So we phrase it accordingly, a decrease by 16 pi inches squared. So we're seeing that the differential is very useful. We can actually approximate function values, and we can also approximate change in function values. And we are done.